Today we're going to talk about properties of functions. Make sure that you have watched the introduction to functions and the linear versus nonlinear videos before you watch this one. Functions have all of the following properties. Besides the ones we already know about, functions can be increasing and decreasing, they can be positive or negative, and they can have x and y intercepts. When I say increasing, that means that your graph is going up as it's going right. In other words, it has a positive slope. When I say a function is decreasing, it means the graph is going down as it's going right. In other words, has a negative slope. If I'm going to have a zero slope, that means it's neither. A graph can be increasing and decreasing on the same graph. So one thing you need to know before we get started here is when I'm talking intervals, when I'm talking increasing and decreasing, I have to only use numbers along the x-axis. It's almost like the x-axis is a track and I'm a train that's stuck moving along that track from left to right. Always from left to right. So I'm going to start way out here at negative infinity. So as I start at negative infinity and I'm moving forward, what is my graph up here doing? Is that increasing or decreasing? That's decreasing. That part of the graph has a negative slope. So for my interval, I'm going to say that I start at negative infinity, and as I'm moving along my track, at what point does my graph stop decreasing? Right here when x is 0, right? That's where it stops going downhill. So I'm going to say all the way from negative infinity to 0, my graph is decreasing. What happens right here at 0 as I'm moving forward? What's happening to my graph now? My graph starts to increase. That's where my graph starts to have a positive slope. So I'm going to say from 0 and all the way to positive infinity, my graph is increasing. This graph, when I'm clear out here at negative infinity moving forward, this graph has a positive slope then. So it's increasing starting at negative infinity. And for what x value does it stop increasing? It stops increasing right here at that point, and that has an x value of negative 4. So I'm going to say from negative infinity to negative 4, this was increasing. Starting at negative 4 moving forward, my graph is now decreasing. So from negative 4 to what point? My graph stops decreasing right here, which has an x value of 8. So between negative 4 and 8, my graph is decreasing. What happens here at 8 again? From 8 moving forward, my graph starts to increase again. So from 8 to infinity, I have a positive slope. Because I have more than one place where it's increasing, I'm going to put a U for union. This means that it's increasing in both places. Next, moving on to positive and negative. Functions are positive when the graph is above 0, right? Above the x-axis, and negative when it's below the x-axis. So again, we're looking now for above and below. When I'm clear out here at negative infinity, we're still stuck. We're a train on the track of the x-axis. So clear out here at negative infinity, is my graph going to be above or below? Positive or negative? It's going to be negative. So I'm going to say clear out at negative infinity. Starting at negative infinity, my function's negative. And where does it stop being negative? Right here at negative 2. That's where my graph goes from being below the x-axis and starts being above the x-axis. So from negative infinity to negative 2, my function's negative. What starts right here at negative 2 moving forward? All of a sudden our graph is above the x-axis all the way until it hits over here at 8. So I'm going to say from negative 2 to 8, my function is positive or above the x-axis. And from 8 moving forward, we're below the x-axis again all the way to infinity. Remember to put a u in between to show that it's both. Last but not least, functions also have intercepts. Intercepts are where the function crosses an axis. We have dealt with y-intercept all year. The y-intercept, remember, is where my line crosses the y-axis. My x-intercept acts the same way. It's where my line crosses the x-axis. So in this particular graph, where does this curve meet the y-axis? All the way down here at negative 6. So my y-intercept is negative 6. How about the x-intercept? Where does this curve meet the x-axis? Do you see how it meets in 2 places? That means I'm going to have 2 x-intercepts. I can have as many as I need. I'm going to say that my x-intercepts are negative 4 and 4. I don't want to put parentheses around this and have it mistaken as a point. On a side note, intercepts are called zeros, and you are going to hear them called zeros for many years to come. So let's practice just a little bit. Take a look at this graph. We notice that it's a function. It's also linear. Is this function increasing or decreasing? Or both? Well, in this case, going from left to right, this has a positive slope, so this is an increasing function. What are my intercepts? What's my x-intercept? Where does it cross the x-axis? Well, it crosses right here at 2, so my intercept is 2. And how about the y-intercept? Where does it cross the y-axis? Down here at negative 4, so my y-intercept is at negative 4. Where is this function positive? Remember, positive means above the x-axis. Moving along my x-axis track, it starts being above the x-axis at 2 and is above all the way from there on. So from 2 to infinity, we're positive. Out here at negative infinity, all the way until I get to 2, my function is below the x-axis or negative. So from negative infinity to 2, we're negative. What is the value of the function when x is 3? Means that right here where x is 3, I'm going to come up here and find my y value. When x is 3, y is 2, so I'm going to say I have a value of 2. Here's a different graph. Now this actually gets really, really close to the x-axis but never actually touches it, just so that you understand what you're looking at. Is this function increasing or decreasing? Is it going uphill or is it going downhill? Since this is going uphill, again, this is increasing. How about our intercepts? Do we have an x-intercept? Remember, I just told you that this is going to get really, really close to the x-axis but never actually touch. So I have no x-intercepts. How about a y-intercept though? Does this touch the y-axis? It does right here at 1. So my y-intercept is 1. Where's the function positive? Where is it above the x-axis? It is always above the x-axis. So in that case, I'm going to say from negative infinity to infinity. And where is the function negative? It never is negative. And this time, what's the value of the function when x is 3? In other words, when x is 3, what is the y value? This is clear off the chart, so it's kind of hard to tell. So sometimes I can simply take my x value and put it into my equation. 3 to the third power is 27. Your assignment is the Properties of Functions worksheet. Good luck!